This is a video on piecewise functions, and I'm going to combine these two videos. So if you're watching this and you've already understand this level, you can fast forward to the marker that I have written on there, and you can just skip to the highly proficient because I'm going to do it next. So with piecewise functions, one of the things to keep in mind is that they're all going to be linear functions on the ones that we're giving you. It doesn't have to be. You could have piecewise functions that have pieces of all sorts of different kinds of functions. It's just different pieces of different functions. So it can be any kind of function. But to make it easy on you, to help you understand kind of what's going on, we're going to just limit them to be linear. And so remember that those equations follow y equals mx plus b, where m is the slope, which is rise over run, or the change in y over the change in x, and b is the y-intercept. And so it is useful to make a table of values. This describes the piece of the functions. These are the functions. And so let's talk about this just a little bit here. Let's make a quick table of values, x and y. So you could do more. I'm gonna do 7. And I'm gonna put -3 right in the middle, because -3 is that point where they divide. X less than -3, those are the ones on the left of -3. And x greater than -3, those are the ones on the right. And so x is less than -3. Values that are less than -3 could include -4, -5, -6. You could go bigger, smaller, but all of those values are less than. I'm going to use this here. These values right here are less than -3, and so this is what we're going to put where we're going to put those x values to determine what's happening. And then we've got the values where x are greater than or equal to -3, and those are going to come down this way. And that's going to be this right here. And so values greater than -3 are the values to the right of -3. And so that would be -2, -1, 0. You could keep going, but this is what's happening. And so if I look at these values up here, -6, then I put -6 right there. If I put -6 right there, I got -6 plus 2. Well, -6 plus 2 is -4. And so at -6, I'm at 1, 2, 3, 4, -4. And let's see what happens at -5. If I change that to -5, I have -5 plus 2. -5 plus 2 is -3. So at -5, I'm at down 1, 2, 3, -3. -4. -4 plus 2 is, so if I change this to -4, -4 plus 2 would be -2. -4 down, -2. -3. At -3 plus 2 would be -1. So here, -3, 1, 2, 3, down 1. And so I can see kind of what's happening over here. This has a slope of 1. Its m value, its slope, its rise and its run is 1. It's that number that's before the x, which if there is no number, we understand that to be 1. And we can see that, yeah, it's rising 1, running 1, rising 1, running 1, rise 1, run 1. And so that's its slope. Up until you get to -3. And so at -3, I want to say, well, what happens over here? When x is equal to -3, there's nothing to plug in here. There's no x value. And so it just says this. Remember that f of x is the same as y. Y equals -1. At negative 3, y equals negative 1. That's the same as it was on the other side, so we're good. They meet up. What about at negative 2? Well, at negative 2, y equals negative 1. Okay, negative 1. And what about negative 1? With negative 1, well, see, there's nothing to change it. So negative 1, y equals negative 1. What about 0? Negative 1. What if I put on more? What's 1? Oops, here. What about 1? 1, yeah, well, it's greater than, 1 is greater than negative 3, so y is negative 1. And so this is just constant here, constantly. It's constantly negative 1. Here, I think it's important to note that when you have, I'm going to talk about this guy that I like to talk about, slope man. If you go up to the right, that's a positive slope. If you go down to the right, that's negative. If you have a perfectly horizontal line, that slope is 0. If you have a perfectly vertical line, there is a change in y, but no change in x. And so you're trying to like dividing by 0. You can't. That is undefined, and so we use a u. And here, if you make a little circle here, you can see this guy looks like slope man. He's here to help you with your rate of change. So what I'd like to focus on here for you is that this horizontal line has a slope of 0. Its dimples of this man are zeros, and that's just like this. So its slope is 0. So if I'm going to y equals mx plus b, and I said the slope is 0, so that's 0x. And where does it cross the y-axis? Well, it crosses at negative 1. But if I simplify this, 0x minus 1. Well, 0 times anything is 0, so I got 0 minus 1, and that just goes to minus 1. So what do I have? Y equals negative 1. If you have y equals to a number, which is what we have here, y equals negative 1, and there's no x, then that's constant. It's just going to be constantly whatever that value is, and it's going to be a horizontal line. Its slope would be 0, and hopefully that helps. All right, so 735, we'll move over here. I'm going to write it right over here, 735. Okay. Now, on this one, we have the graph when we have to write the equation. So again, we want to determine what is the slope of these lines and what is the y-intercept. But it looks like where they stop, where one part of the function stops or begins is right here when x is equal to 1. And so on the one side, I'm going to have x is less than 1, and on the other side, I'm going to have x is greater than 1. And I need to have an equal sign because they do meet up. But I don't care where you put it. You can put it on the top one, you put it on the bottom one. It doesn't matter. But don't put it on both. So here, I'm going to say x is less than or equal to 1. And that, the values that are less than 1, I'm going to put a little star here. That's this side. And if I put like a little square here, just a little square just to make it a different shape. The values where x are greater than 1, that's over here. And so just so that you can keep in mind, like, where do I put what? Here I can see that the y-intercept is 3. And it's a straight line. So its slope, m, is 0. So if I say, mx plus b, 0x, and its plus, its b is, its y-intercept is plus 3. 0x is just 0 plus 3, so it's just 3. This is just 3. There's no x with it because it's constant. If I go over here, Willow, this goes over 1 and then down 1. That's a plus 1 in x and a minus 1 in y. And so its slope, m here, is negative 1 over 1. And that just simplifies to negative 1. Now, it does not cross the y-axis. It only goes If I'm going to use let's say I use a little highlighter here. This only goes up to right there. It's not crossing the y-axis. But we would say, well, what happens if it continued in that same way? It would cross, in this instance, at 4. And so we would say that its b value is 4. So if I want to write this, I would write y equals mx plus b. M is -1, x plus 4. I usually am not going to write that 1. So this is going to write -x plus 4. Down here, -x plus 4. And that's what this looks like. I realize this is a little bit tricky, so practice. You can look at other videos online, look up piecewise functions, and you'll get plenty of things to practice with. So good luck, study, you got this.